Today I'm gonna talk about the vertex form of quadratic function. The vertex form of quadratic function can be defined as fx equals a times x minus h square plus k. Okay, and from this vertex form of quadratic function, we can tell the vertex is hk. Okay. Now let's take a look the following example. Sx equals x squared minus 10x plus 21. That is not vertex form, so we want to transform it to vertex form. Okay, so how to transform it? We're gonna use the technique of completing the square. Okay, and the formula is here: a squared plus or minus 2ab plus b squared equals a plus or minus b squared. Okay, and here if the middle term is positive 2ab, that means here we should be use plus. If it's negative 2ab, that means here should be a minus. Okay, should be minus. So on the left hand side we have 1, 2, 3 terms. Okay, 3 terms. Now let's go back Sx. We're gonna focus on the first 2 terms. Okay, the first 2 terms. X squared, the second term is negative 10x. Now let's compare the first 2 terms with the formula here. So we can tell that for the first term, a is x, because here's a x squared, here's a squared, should be a equals x. Okay, and we compare the second term. Here's negative 10x, here's 2a, should be a negative 2ab. Okay, because here's a negative, here should be a negative. So we can use negative 2ab equals negative 2x, negative 10x. Okay, and then from the second expression we can find the b. How to find it? We divide by negative 2a for both sides, and we can cancel out. B equals 5x over a. Okay, 5x over a. And we can tell a equals what? A equals x. We cancel out, that equals 5. 5. Okay, we find the b equals 5. That means we can construct the third term for the Sx. Okay, we find the b equals 5, so we can construct the third term. The third term should be a b squared, so we plus b squared. Okay, so that means 5 squared, and since we add 5 squared, we need to subtract 5 squared plus 21. Okay, now the first 3 terms we can construct the complete square, because we know a is x, b is 5, right? So we're gonna plug in here, right? Plug in here, so it should be x. Plug in here, a is x, subtract b is 5. Okay, b is 5. Here I use minus, because what? Because here is negative. Okay, here's a negative. So x minus 5 square and here is negative 25 plus 21, and we can simplify it. X minus 5 square, here's minus 4. Okay, now that is the vertex form. Okay, now let's take a look the first A problem, the 8th problem, how to find the intercepts. Now the first thing, we try to find the x-intercept. The x-intercept should be y equals 0. Okay, so we just let this term equals 0. And we can use quadratic formula to solve it. A equals 1, B equals negative 10, C equals 21. Okay, just plug in the quadratic formula. We have negative b, positive, negative, b squared minus 4ac divided by 2a. Okay, and we can plug in b is negative 10, positive to negative, b squared is negative 10 squared minus 4ac times 1 times 21 divided by AA is 1. Okay, so we have negative, negative, positive, and 100 subtract 84, and again we have 10 positive square root of 16. Okay, and square root of 16 should be 4. So that means we have two roots. One is 10 minus 4 equals divided by 2 should be 6 over 2 is 3. The second one should be 10 plus 4 over 2 should be 14 over 2 should be 7, right? So two roots, that means two x-intercepts. And for y-intercepts, that means x equals 0, right? So plug in x equals 0. We have 0 squared minus 10 times 0 plus 21 equals 21. Okay, now let's try the problem B. Problem B means vertex. Okay, that means we need to compare the vertex form with here, right? With here, so we can either tell h equals 5, k is negative 4, because we can plus negative 4. Here the plus k, k is negative 4. So we have h is 5, k is negative 4. Okay, k is negative 4. Now, for problem C, we can draw a draft of the graph. Okay, a draft of the graph. Now we can draw the draft of graph here. And we have vertex, that is 5, negative 4. It's here, and the index x-intercept is 3, 7. So we can connect all the points. And the vertex is 5, negative 4. Okay, now we can find the lowest point in the curve should be phi negative 4. So the minimum equals negative 4, because minimum is always about y value. Okay, y value. And D, the range. The range, as we can see, the minimum is negative 4, so the y value is always greater than or equal to negative 4. Okay, negative 4. Or you can write down as negative 4 infinity. Okay. Now let's take a look the second example. For the second example, we have Sx equals negative 5x squared minus 10x. Okay, and again we're gonna use the formula a squared plus minus 2ab plus b squared equals a plus b plus or minus b squared. Okay, we have three terms. Now let's take a look the Sx. So we need factor the negative 5. Okay, negative 5, because we want to construct the complete square. So we need factor negative 5. That should be the a, corresponding the a in the vertex form. Okay, so things we can tell here, negative 10x can be written as negative 5 times 2x. So that means we can factor negative 5. We have x squared, factor negative 5 should be 2x. Okay, 2x. Now we're gonna focus on these two terms. One is x squared, another one is 2x. Now we're gonna compare these two terms with the terms in the formula. So we can tell the first term, a is x. The second term, here is a positive, so it should be a positive 2ab, right? So we let positive 2ab equals 2x. Now we can find what is b. Okay, divided by 2a for both sides. And we can find b is x over a. And again we find a equals x, right? We plug in a equals x, and we find the b equals 1. Now we can construct the third term for the Sx, because we find the b is 1. Okay, is 1. So we can construct the third term. The third term is b squared, right? So we have x squared plus 2x plus b squared. Okay, b squared. And if we add 1 square, that means we can subtract 1 square. Okay, and from these three terms, we can construct the complete square following this formula. What is a? A is x. What is b? B is 1. Okay, 1. So we can write down the Sx equals negative 5. A is x plus b. B is 1 square minus 1. Okay, now we can do the distribution. We're gonna have negative 5 x plus 1 square. Negative 5 times negative 1 is positive 5. Okay, we find the vertex form. Now let's try to figure out the intercepts. So let's take a look the x-intercepts. X-intercepts, we just let y equals 0, right? So we have negative 5x squared minus 10x equals 0. We can use the factoring method. Okay, factoring method, we can factor the x. Or you can factor negative 5x. Doesn't matter. If I factor the x, negative 5x minus 10 equals 0. So here we're gonna have two solutions. One is x equals 0, and the other one is negative 5x minus 10 equals 0. We solve it. Plus 10 for both sides. We're gonna negative 5x equals 10 divided by negative 5 for both sides. So that should be negative 2. So we have two solutions. And that means we have two x-intercepts. Now we can try the y-intercept. Y-intercept means what? Means x equals 0. Okay, x equals 0. We just plug in x equals 0 here. Negative 5, 0 squared minus 10 times 0 equals 0. Okay, so that's the y-intercept. Now B, the vertex. Okay, let's go back. The vertex form, we got it. Okay, and we compare the vertex form formula. Here's x minus h. Okay, so here x plus 1 squared, actually we can write down as what? We can write down x minus negative 1 squared, okay, for this term. X plus 1 squared, we can write down x minus negative 1, okay, negative 1 square. Negative should be positive, right? So here the h should be negative 1. So that means the vertex should be hk. H is negative 1. Okay, negative 1. And the k is 5. Okay, k is 5. Now, let's take a look. The maximum and the minimum. Then we need to draw a picture. Okay, we draw a rough picture. Negative 1. And the 5 should be around here. And we have two x-intercept. One is 0. Another one is 2. So we have the curve looks like that. Okay, and the curve have the vertex that is negative 1 and 5. Okay, so from the curve we can tell we have the highest point, so that means maximum equals 5. D, the range should be y less than or equals 5, because the highest point is here, right? Is here. And be careful, the maximum value is about the y value, y coordinate. Okay, so it should be 5. And also, if you want to write the x less than or equal to 5 as interval notation, that should be negative infinity to 5, and should be a square bracket because the 5 is included.